Okay, so what we're going to do today is review or go over the implicit differentiation rules. Okay, so you have a four-step process you need to do. The first step, you need to take the derivative of both sides of the equation with respect to x, collect the terms with dy dx to one side of the equation, factor out the dy dx, and then solve for dy dx. I know this seems very confusing, so let's do some examples. So let's start off with example 1. Let's just take something simple like y equals x squared. We've done this before, so let's start off with the easy side. The derivative of x squared is going to be, you got it, 2x. Here, you're going to take the derivative of y, but you're going to do it as if it's an x in the beginning. So the derivative of y is 1. And then because we took it as a y, we need to tack on a dy dx. This way it tells people that you took the derivative of y, but you're doing it for x. And you, yes, have to do this all the time for y. Well, 1 times dy dx is just dy dx equals 2x. Okay, hopefully that seems simple enough. So let's do another equation. So let's take and reverse it. Let's do x equals y squared. So the derivative of x is 1. And then we're going to take the derivative of y squared. So the derivative of y squared is just 2y, but because we took the derivative of y, we tack on dy dx. Now, around, I think, rule 4, we have to solve for dy dx. So what we're going to do is divide both sides by 2y. And you have a final answer of dy dx is equal to 1 over 2y. We know we are done because we have solved for dy dx. Okay, so let's try example 3. Let's take something like x squared plus y squared equals 25. Okay, so the derivative of x squared is 2x plus the derivative of y squared is 2y, but because we took a derivative of y, we tack on dy dx. And the derivative of 25 is just 0. So now what we have to do is solve for dy dx. So what I'm going to do is start off by subtracting 2x from both sides. And that leaves me with 2y dy dx is equal to negative 2x. Again, we have to solve for dy dx, so what we're going to do is divide by 2y. Let me give us some more room. Now, the 2y's cancel out, and we're left with dy dx is equal to negative 2x over 2y. We can clean this up if we need to. We have a 2 on both the top and bottom, so that can reduce to negative x over y. Not bad, right? So let's do another problem. So I think we're on example 4. And let's try y cubed minus 2x plus 5y equals 7. Okay, so take the derivative. So the derivative of y cubed is 3y squared. But because we took a derivative of y, tack on dy dx minus the derivative of 2x is just 2 plus the derivative of 5y. So the derivative is going to be 5, but because there was a y, dy dx equals, and the derivative of 7 is 0. So rule 2 said let's get dy dx to one side and non-dy dx to the other. So what I'm going to do is add 2 to both sides. When I do that, I am left with 3y squared dy dx plus 5 dy dx is equal to 2. Step 3 told us to factor out a dy dx. So hopefully you see we have two terms and both contain a dy dx. And that is what I'm going to factor out. So when I do that, I'm just left with 3y squared plus 5 equals 2. Now what we're going to do is divide both sides by 3y squared plus 5. So my final answer is dy dx is equal to 2 over 3y squared plus 5. Not too bad. A lot of steps, but slow and steady will win the race. Okay, let's look at our last equation, and we need to be really careful. Let's do, I don't know why I put an equal sign. Ignore that. So let's try x squared minus 5x y squared plus 3y minus 10 equals 0. I'm going to go ahead and tell you, here's where you want to be very careful because this will require the product rule. Let me change colors. And if I take and trim that down, you can hopefully see the product rule. Let me make sure I have a small line. Okay, so here we go. Derivative of x squared is 2x. Okay, now we're going to take the derivative of 5x. Here's the product rule, first and second. So the derivative of the first is negative 5 times the second. Notice I am not taking the derivative of y, so therefore I'm not going to have a dy dx. Okay, plus the derivative of the second, which is 2y. Notice I just took a derivative of a y. This is where we tack on that dy dx. Don't forget to multiply it by the first. Plus the derivative of 3y, which is 3. Don't forget that there was a y, so this is going to be a dy dx. Derivative of 10 is 0, so this whole thing equals 0. What I'm going to do is I'm going to take and multiply this out. So we get 2x minus 5y squared. 2y times negative 5 is negative 10xy dy dx plus 3 dy dx equals 0. Okay, by going ahead and multiplying that, we're going to make our life a lot easier. So we're going to go and get rid of, separate our dy dx's from those who don't. So I'm going to subtract 2x and add 5y squared over. Okay. Let me move this down. And when I do that, ooh, that was not straight. So we get negative 10xy dy dx plus 3 dy dx is equal to negative 2x plus 5y squared. Factor out a dy dx, and I get negative 10xy plus 3 equals negative 2x plus 5y squared. Okay, now what we're going to do is divide each side by negative 10xy plus 3. And our final answer is dy dx is equal to negative 2x plus 5y squared over negative 10xy plus 3. You're really going to want to make this thing positive. Please do not, because you got to change all your signs. I can't factor anything else out, so we're going to leave this alone. I hope this helped my little pumpkins with their implicit rules.